So our lesson for today is about properties of logarithms. So one of the things about properties in general is that they're usually used in both directions. And what I mean by that is, let's say, for example, let's do the property of distributing, or the distributive property, which says that if you have something multiplied by two other things that are added together, that is equal to A times B plus A times C. So, I mean, we've been using the distributive property a lot, so this should be familiar. But the thing I want to point out is that we often use this property in both directions. So sometimes we have expressions like this, and it's more useful to have them written like this. So we distribute to get this form. But sometimes we're given something that looks like this, and it's more useful to have it in factored form. So we factor it and put it back into this form. So properties are often used in both directions, and it depends on what form is going to be the most useful for you. So in our lesson for today, we're learning about properties of logarithms. And in many of these situations, you'll be converting them in both directions. And we'll go through some examples of what this looks like. But the main idea is that there's relationships where you can rewrite expressions and still have them equal to each other. Okay, so just as a reminder of what a logarithm is, logarithms have bases, and the question that a logarithm is asking is basically, what exponent do you raise this base to make it equal the argument y? So this number in the logarithm is called the argument, and the logarithm calculation figures out what exponent b needs to be raised to make it equal y. And we did this yesterday by converting them to exponential form. And in future lessons, we'll also learn how to do this with a calculator for when they're not whole numbers. So the logarithm properties that we're learning about today are these 7. And you can just memorize them or write them down in your notes and use them. But I'm also going to show you why they're true. So these are kind of the main pieces of information you need to know for your homework. And I just want to quickly go through and explain why each one of these properties is true. So for this first one, it says that the log of any base, regardless of what b is, of 1 is always going to equal 0. And what this means, or the reason why this is true, is because if we write this in exponential form, we would say b to the 0 power equals 1. And that's obviously always true because anything to the 0 power does equal 1. And so this property is basically kind of restating this exponential property that we already know. So this exponent property translates into this logarithm property. Then this one is very similar because this one says that anything to a power of 1 will equal itself. Well, that's also true. That's just like one of our basic exponent rules. And if you convert it into logarithmic form, it gives you this property. For the next one, the way that it's easiest to think about this one is to think about what log base b of x is asking for. So whatever this is, it's the exponent that if you raise it to whatever exponent, oh, sorry, you guys can't read yellow very well. Let me change this. So this is basically saying b to what exponent equals x. So whatever that exponent is, if you raise b to it, well, that's going to equal x. Because this tells you what exponent will equal x if you raise b to it. So if you do b raised to that, it will just equal the x. So the way that I kind of think about this is that taking b and raising it to log base b cancels each other out, which also kind of makes sense because exponents and logs are inverses of each other. So it makes sense that if you raise a b to log base b, that they would cancel out. Kind of like if you square a square root, how they cancel each other out because they're inverses. It's kind of like that type of a thing. And then this one is similar, because if you do log base b of b to the x, then that part will cancel out and it just equals x. You could also think about that as, so like if you think about what this means, it means b raised to what power equals b to the x? Well, obviously that's just going to be x. So these two properties, well, actually really the first four are all pretty self-explanatory, but these two are really useful because we'll use them when we start solving equations to cancel out the bases of powers. Any questions on those properties so far? Okay, let me actually change my color to a different color. Let's do this next one. Okay, so these next three are basically logarithm versions of exponential rules we've already learned. So you know how we learned that if you have any number, let's use different variables. Let's say we have k raised to some variable, and then we have k raised to another variable. Do you guys remember about what exponent rule allows us to simplify this? Yeah. Perfect, yeah, because if I have a number of k's multiplied and b number of k's multiplied, and they're all multiplied together, the number of k's I would have would be a plus b. So everybody good with that exponent rule? So this logarithm rule is basically the logarithm version of this, because logarithms figure out what the exponents are. And so like if you add the exponents together, that will equal the multiplication of the two powers. Does that make sense? So the way that we'll apply this is if we ever have a log of two things that are multiplied, or even three or four things, but if you have the log of things that are multiplied, you can expand them out into separate logs, which can be helpful in some situations. Or if you have separate logs that are added together, you can rewrite them as a single log where the arguments are multiplied. And it's basically a logarithm version of this rule. And then similarly, this rule is a logarithm version of our division exponent rule. Because remember how if you have two powers that are divided, how you can subtract their exponents like this? This is basically the logarithm version of that. And then our last one is a variation of our power rule. So you know how in exponents, if we have like k raised to the a raised to the b, how we can multiply these exponents? Because like, let's say for example, a was 2 and b was 3. Well, if you have k squared cubed, that's 3k squareds, which ends up being a total of 6k's. And it doesn't matter what the exponents are. So this one is basically a version of this, because it's saying if you're finding the logarithm of a power, well, you could think about this as like a power raised to an exponent, or you could just multiply the two exponents together. So this represents an exponent and this represents this exponent. Any questions on that? Okay, and again, you don't necessarily have to know where all of these come from. You just need to know all of these. So if you want to take a picture or a screenshot or write them down in your notes or something, you can go ahead and do that. And I have them on the next few slides as well. So if you're writing them down, I'll have them on the next few. Okay, so let's talk about how we can use these logarithm properties to simplify logarithmic expressions. And let's maybe do one of the harder ones. Okay, so on this one, we're given the expression log base 6 of x cubed y to the 4th. And what they want us to do is they want us to take this logarithm, which is a single logarithm because it's log base 6 of all of this stuff. And it's a rather complicated logarithm because the argument has an x and a cube and a y and a 4th, and it has like a lot of stuff in it. And they want us to expand it to a simpler form where rather than having the arguments be really complicated expressions, they're just like single numbers or as simplified expressions as we can get them to. So what we want to do is we want to look at our argument for the logarithm and look at what structures it has. So I notice that we've got x cubed and y to the fourth multiplied. And we've also got exponents, like we've got an x cubed and a y to the fourth. And so when I look at my, when I look at my different properties, which properties do you guys think will be useful in simplifying or expanding this logarithm? Okay, yep, 5 will be useful because that deals with multiplying things in the argument. What other thing might be useful? Yep, 7, because that's the one that deals with exponents. So we say, okay, well, I guess you could say the outermost structure is multiplication, because like that's the last thing we would do if we were doing order of operations. So I'll expand that out using property 5 and write this as log base 6 of x cubed plus log base 6 of y to the fourth. Everybody good with how I got from here to here using property 5? Okay, then the next thing I need to do, let me move this over to the side actually. There we go. So then the next thing I need to do is I need to say, okay, well, this is more expanded, but these arguments are still pretty complicated. So now I can use property 7, like you guys said, and this one is going to be rewritten as 3 times log base 6 of x. And this one will be rewritten as 4 times log base 6 of y. And this is now fully expanded and simplified because there's no other properties I could use to simplify it further. And so now I just look and see, well, what numbers do I have in these spots for A, B, C, and D? Because this thing here, they're basically just making it so that you can answer the problem because it's kind of hard to describe how they want you to write it. So they're just asking you to fill in the gaps for A, B, and C. So the number that's in the spot for A is 3. The number of the thing that's in the spot of B is X. The thing that's in the spot of C is 4. And the thing that's in the spot for B or for D is Y. And so that would be Y. And so this and this are equal to each other. Just like when you distribute something or factor something, the two expressions are the same. These two things are talking about the same thing. They're just doing it in different forms. Okay, so let's do another example. Let's do question 12. So on question 12, we have log base 8 of 4 over x times y. Do you guys feel like you're ready to try one on your own, or do you want to go through this one together? Give me thumbs up if you're good to try it on your own. Thumbs down if you want me to do it right now. Okay, we've got kind of a mix. So how about I give you guys 1 minute to get as far as you can, and then we'll go through it together. Okay, so on this one, where did you guys start? Which property did you use? Okay, so 6 will be useful because we've got division, and we've got that in there. We'll also end up using property 5 as well because you've got multiplication inside of the division. But we will use property 6 first because this multiplication is inside of the division. So you want to expand out the division part first and then expand out the multiplication part. So I'll use property 6 to write this as log base 8 of 4 minus log base 8 of xy. Now that I have this written as log base 8 of xy, then I can use property 5 to expand that out into addition. So I'll have log base 8 of 4 minus log base 8 of x plus log base 8 of y. And this minus is going to be applied to the whole thing because this is like the negative was applying to this entire logarithm. So when you separate the logarithm out into two terms, you need to make sure the negative applies to both of them. So if I distribute that negative to both of my terms, I end up with negative log base 8 of x minus log base 8 of y. And so to put it in the form that they asked for, basically A would be 4, B would be x, and C would be y. So essentially, whenever you're adding logarithms, they're going to be multiplied in the numerator. If you subtract logarithms, those are going to end up in the denominator. Any questions on that?
So A would be 4, B would be x.
Yep, exactly. All right, let's do a quick check-in. Scale of 1 to 5. How are you guys feeling about this stuff? Okay, awesome. Let's do another example that's a little bit more complicated. Let's do this one. Okay, so on question 16, we're given log base 12 of the 4th root of y plus 1 over y plus 4. And so when I'm calculating out this one, when we look at this structure of our argument, that's pretty complicated. You have the 4th root of a fraction, and inside of the fraction, you have addition. So what is the outermost operation that we're working with? Like, what's the very, like, if we knew what y was, what's the very last thing we would do with order of operations? So that would actually be our first thing because we need to simplify this fraction. Yep, so we have division, and the very last one would be the 4th root. Does that kind of make sense? Like, if we knew what y was, we would like figure out the top, figure out the bottom, then we would divide, then we would do the 4th root. And so our outermost operation is the 4th root. Now, we don't have anything in here that talks about roots, but how can we rewrite roots where it does fit in one of these properties? An exponent, right? Because roots are fractional exponents. So if I rewrite this as log base 12 of y plus 1 over y plus 4 raised to the 1/4 power, then I can use property 7. And so anytime you see a root, just think about it as a fractional exponent. So I'll use property 7 and say this is equal to 1/4 times log base 12 of y plus 1 over y plus 4. And now my outermost operation is division, because that's like the last thing I would do here. So I say, okay, well, according to my division rule, I can rewrite this as 1/4, and the 1/4 is going to be multiplied by the whole thing, because the 1/4 was multiplied by this whole logarithm. So when I rewrite this, I'll multiply 1/4 by all of it. So I'll do log base 12 of y plus 1 minus log base 12 of y plus 4, according to my division rule. And so if I do 1/4 times all of this stuff, that's going to give me 1/4 log base 12 of y plus 1 minus 1/4 of log base 12 y plus 4. We can do that. And then we can't simplify this any further because we don't have any logarithm rules that simplify addition. Because the reason why we don't is because, remember, logarithms are asking like what exponent do you raise it to that equals this? And like, there's no way to simplify it if you have addition in your argument. And you can see like the only rules we have are multiplication, division, and exponents. So this would be our final most expanded answer. So when we answer, or like when we type in our answers, A would be 1/4, B would be y plus 1, C would be 1/4, and D would be y plus 4. And that would be how we do that one. Okay, any questions on how to deal with roots? Okay, I also want to point out, like, if it's easier for you to think about it this way, do you remember the division rule for roots? How, like, if you have two things divided, you can take the root of them separately. So if you wanted to, you could have thought about this as the 4th root of y plus 1 over the 4th root of y plus 4 and use the division rule first and then use the exponent rule to bring out the 1/4. So sometimes you don't have to do it in a specific order. You just have to make sure that like you're applying the properties correctly. All right, so you'll have some questions like this where they give you a single logarithm with a complicated argument, and they ask you to expand it out into multiple logarithms with simpler arguments. And then you'll also have some questions towards the end that go in the opposite direction. So in this one, we're given the expression 1/4 log of x and -2 log of y minus 5 log of z, and we're asked to simplify this and make it a single logarithm. So in this case, rather than using these rules and converting them this direction, we're going to use these ones and convert in that direction. Because we're taking simple logarithms and combining them into a more complex one. So on this one, which properties are you guys thinking might be useful? Okay, so 6, yep, that looks like that will show up because this is where you have logarithms subtracted. And we do have some logarithms that are subtracted there. Any other ones that might end up being useful? 7, okay. Yep, that one will help because that one allows us to take a coefficient of a logarithm and turn it into an exponent. And also, I don't know if we've talked about this yet. Do you guys know what the base is of these logs? I don't think we've talked about it yet. Yeah, it's 10. So with logarithms, you can have any number as a base, but the most common number that we have as a base is 10 because our number system is based on 10. You know, like our place values are like 10, 100, 1,000, 10,000, etc. And so anytime you see a log that doesn't define what the base is, that means that it's base 10. And we'll talk more about that in our next class because that's when we're going to start using our calculators. But the log button on your calculator is log base 10. So in this case, if we want to simplify this, we will be using both property 6 and property 7. And which one do you guys think we should use first? Yep. And in fact, we have to use 7 first because property 6 doesn't account for any coefficients. And so we have to use property 7. And we can write this first expression as log base 10 of x to the 1/4 power. Then for my second expression, I can write this as minus log base 10 of y squared. And then the next one is minus log base 10 of 2 to the 5th power. Or no, sorry, that's a z. It looked like a 2. It should be a z. Any questions on that? Okay. And then from here, we'll set this up and we'll say, okay, well, now that I just have logarithms that are subtracted, now I can apply property 6. And property 6, if I apply it to these first 2 logarithms subtracted, I'll get log of 10 of x to the 1/4 divided by y squared. And then I'll still subtract log base 10 of z to the 5th. But now I have 2 logarithms subtracted again. And so I can do log base 10 of x to the 1/4 over y squared. And that is divided by z to the 5th. Now, this is kind of complicated to simplify because you have a fraction divided by something else. But you can think about this as multiplying by the reciprocal of z to the 5th, which would be 1 over z to the 5th. Is everybody good with how I did that? Because I'm taking this and dividing by z to the 5th by multiplied by the reciprocal. And so that means that my fully simplified logarithm will be log base 10 of x to the 1/4 over y squared times z to the 5th. So this is a single logarithm that represents the same thing as the expression they gave me. Now, in my opinion, there is an easier way to do this. Would you guys like me to show you how, like this step of like doing the multiple divisions? Okay, so another way that you could approach it is at this first step, when we changed it to exponents, you can think about your coefficients as being negative numbers. So rather than doing a 2 here, you can put a -2 here and add them. So the 1/4 would still be the same. You'd write this, you'd write this as log base 10 of x to the 1/4. And then at this step, I'm going to take -2 as my coefficient. I'm going to add log base 10 of y to the -2. Everybody good with how this is different from this one, but it means the same thing? And then you could do the same thing here. So we'd say log base 10 of z to the -5. And in this case, since they're all added together, because I brought the negative into the exponent with me, since they're all added, I can just multiply the arguments together. So I'll get log base 10 of x to the 1/4, y to the -2, z to the -5. But negative exponents create reciprocals. And so I could rewrite this as log base 10 of x to the 1/4 over y squared z to the 5th. So regardless, you still end up with the same answer either way. I just like doing it this way because then you don't end up with this step where you're like trying to divide a fraction by something else. But you can do it either way and it will give you the same result in either case. Any questions on that? Okay, let's do another example of this one. Well, that one's kind of actually just about like what we did before. Okay, why don't you guys go ahead and try this one? So this one is 2 log base b of x minus 2 log base b of y. Okay, so which property did you guys use first? Okay, yep, because 7 will allow the coefficients to be exponents. So we can rewrite this as log base b of x squared. And then I can write the second one as log base b of either doing y squared and subtracting it, or you can do y to the -2. It kind of just depends on what you prefer. I'll write it like this, so where this is a minus. And then once I have it to this point, then I have 2 logarithms that are subtracted. And so what property could I use to simplify this? Yep, if I use property 6, I end up with log base b of x squared divided by y squared. if you had chosen to do it the other way, so if you had written this as log base b of x squared plus log base b of y to the negative 2, so like if you kept the negative with the coefficient, then you would get log base b of x squared y to the negative 2 by property 5, because property 5 is where you add the log, like if you're adding logarithms, you can multiply their arguments. And that would still end up being the exact same expression because you'd get x squared over y squared when you make the reciprocal with the negative. So it doesn't matter which one out of the two you do, you can just choose whichever one you think makes the most sense to you. So I think that's pretty much everything you need to know for your homework. The first few questions on your homework are like super, super easy. And on some of them, you may need to use what we did yesterday in order to solve them. So for example, on question 5, we're asked to find log base 3 of log base 3 of 27. So this part doesn't really match any of our properties. And so you can't use a property to simplify it, but you can use what we did yesterday to simplify it, because this is basically saying 3 to what exponent equals 27. And what would that exponent need to be? 3. And so this part all simplifies to be 3, and you end up with log base 3 of 3. And you could also do this and you could say, well, 3 to what exponent equals 3? And you would know the answer was 1. Or you could also use property 2, which says that log base b of b, regardless of what b is, will always equal 1. So some of them you may need to use what we did yesterday to simplify them before a property will apply. But the first few questions are basically just like these easy properties, because most of the stuff we worked on today was these last 3 because they're the harder ones. But the first part of your homework will ask you a couple questions on that stuff. So I'll let you guys go ahead and get started on your homework. I'll also go back to this slide if you need to take a picture of it or write down the properties. And if you have any questions, let me know.